Hi everyone, today I'm excited to introduce how to install SpatialView and let it run on an example dataset. So firstly, this is our bioarchive paper, and this is our GitHub website. It contains lots of useful information about how to run SpatialView. And before I proceed to the actual tutorial, let me first brief you what SpatialView is doing. So let's say you get some spatial transcriptomics samples. And what people tend to do will be normalization, integration, clustering, find marker gene, and do group level comparison. SpatialView don't focus on any analyzation step. It focuses on once you finish analyzing your results based on your choice of analyzation pipeline, how to help you visualize the results you analyzed in a better way. So it's a visualization tool. So how it works will be once you finish analyzing your data, you pass your analyzed results into SpatialView, and it will pop out a web browser that looks like this. This will be the main page of SpatialView, and then you can explore the data that you analyzed. So for example, on the right hand side, there is a list of marker genes that you identified based on your methods, and the clusters that you identified based on your clustering method, and visualize the dimension reduction you did, and do some group level comparison. I will now talk about how to use SpatialView in detail, like how to explore this web browser. This is covered in another tutorial. In this tutorial, I will just tell you how to prepare the data that SpatialView needs so that it can pop out this browser for you. It's really straightforward, but let's go through everything in detail. So firstly, you can see this is our SpatialView tutorial page. Today, I will focus on using SpatialView in R. Using it in Python is really similar. And you can see here's two tutorials. So today, I will use the Surat object tutorial. Another one is really similar. So I will just use Surat as an example. So firstly, you can see in the first cell block, it is just talking about installing SpatialView and load the required packages and install some other extra package if needed. And then here is the read and process data part. So our example data can be downloaded from this place. So click on this link, it will direct you to this website. And then you just click on download, and the data will be downloaded in a tar file here. So I download it in my SpatialView tutorial folder as a tar file. And this code is doing like if you unzip the tar file and arrange the data exactly like a Surat input. So you can see this is a typical input that Surat can read and construct Surat object. Okay, and then once we finish unzip the data using this code, we will read data as Surat object, and then process the data. Basically, first quality control. In this case, we filter out some low UMA count spots and then high mitochondrial count spot, and then do normalization and integrating using Surat pipeline, and do clustering. So the integrated data is stored in the integrated data object, and visualize the cluster. And then perform finding marker genes based on pseudobulk by running t-tests comparing each cluster with all the rest of others. So you have your freedom to alter any of the steps that listed here in the tutorial code. The tutorial code is just to provide you a general workflow of what people in general do to get example data that can be put into SpatialView. Okay, so let's see in my R. So this is the exact same R code copied from the tutorial, and you can see my UMap plot here. And by doing marker gene finding, I got a list of marker genes associated with different layers. Okay, now we got some first step analyzation results, and let's use SpatialView to visualize them. To use SpatialView, we still need a few more information. So first one is data dir. So you can see those are the file paths towards the each folders corresponding to different samples. So you can see those are the folders. So those are the data paths towards those folders in the original data. And you also want to specify an export path. So that is the main directory that you want SpatialView to store all the analyzation results in. So let's see this. So in my case, I construct a subfolder under the SpatialView tutorial folder as auth. And also sample information. So basically you can see those are my samples. You can see from here. And I add sample information to them. So this is the data frame. And now we get everything we need for SpatialView. So let me explain those parameters of SpatialViews. So the first thing is integrated data. It is the surrogate object that you can see we previously performed integration and everything later on. So that is a surrogate object containing the integrated data. And the data dir we just saw. Export path. Project name is that SpatialView will construct a subfolder under my auth folder. And that is the name of that subfolder. So you can change whatever you want, change it to whatever you want. And clusters column is where to find your cluster in the integrated data. So since it is a surrogate object, it will be by default be surrogate clusters. And the run expression is when you visualize the genes expression on SpatialView, how much you want to run it. So this is say by 2 decimal points. And then cluster genes, this is the gene list you saw before. So this is this gene list. And sample information, you already saw that. Okay, and then that is everything we need to input for SpatialView. Let's just run this code. You can see now SpatialView is preparing the data. So it stores all your analyzation results in this format under the TME folder, you can see. Okay, and then now you can see it pop out a web browser containing all the samples and my analyzation results again to me. And you can see for those little blue lines on the samples, that means that sample is still being loaded. Sometimes you need to wait for a few minutes because sometimes we have big samples and we have lots of samples. Okay, now we loaded all the data. And you can see here is the cluster list, gene list. So marker genes associated with different clusters that I identified previously. So now you can again use SpatialView's functions to explore our data. Also, I want to add one more thing. So suppose today you use SpatialView to explore your analyzation results. And what about the second day? You still want to access the results. How to do that? you don't need to rerun everything I just showed you, like all the things like data reading, normalization, integration. Nothing is needed anymore because, as you see, SpatialView already stored all the analyzation results in this folder. So what you need to do is just firstly open a terminal, cd to the folder that contains all the analyzation results. In my case, it is in the TME folder, right? So just go to the TME folder. And then type this. And choose your favorite port number. Let's see, I want this. And now you can go to your web browser and type in this port. And now you can see the data is again being loaded. And you can explore your results again. Okay, so basically that is all I want to talk about in this installation tutorial. I hope you find SpatialView to be an interesting tool. And again, if you are interested in more detail about how to explore things on this web browser, you can check details in another tutorial. And we hope you find SpatialView to be interesting and useful. And again, thank you for watching this tutorial. And please don't hesitate to contact us if you have any further questions.